Okay, hello dear friends, good morning. Such a beautiful, beautiful day. So we will talk about math. And what I am going to talk about is 甲线三角 or 杨辉三角. I will explain it in a bit. 杨辉三角. And in English, it's Pascal triangle. Pascal triangle. If you are learning about mathematics, high school math, you know it. So I will start with a story because this video might be very boring for you to fall asleep. And when I was young, my sister was preparing for college entrance examination. My sister was in high school, and they talk about 杨辉三角, and I felt it so cool. And she started to write the numbers and number patterns, and it was just fascinating. And now my children are in this age of learning about Pascal triangle. They have some homework, so I checked it out, and just fascinated by it, and would like to share some of my knowledge. I hope this can make you fall asleep. If you do not have a pen to write it down, if you have, maybe you will find it something that you can revive your mathematic knowledge. 甲线 is a Chinese mathematician from Bei Song dynasty, which is around 10th century, and about 1,000 years ago. 2018 we are now, so about 1,000 years ago, a Chinese mathematician Jia Xian, he figured out something to make a triangle 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1 1 6 15 20, 15, 6, 1. This kind of very symmetrical and patterned triangle. And it's a beautiful, elegant mathematic term, mathematic expression, and it has a lot of secret behind it. When we see it, we will slowly figure it out. Why it is called Yang Hui Jia Xian? I write it down. His name G-E-R 甲线 甲线三角 三 is 3, 角 is angle, 3 angle triangle. Yang Hui, which is the same name, last name as me, Yang Haiyin, Yang Hui 三角. Yang Hui is Yang Hui was Yang Hui was a Nan Song, South Song dynasty, and which is around the 13th century. He collected the study of Jia Xian, of the previous mathematician, and wrote on a book. And those books, both Jia Xian's recording and Yang Hui's recording, mathematic recording, were collected and reserved. They are in Yongle Dadian, in British Museum or British Library. Anyway, they are now overseas in another country. And so in the 13th century, he collected the previous information and wrote it down and make it into a big name. So now in Chinese mathematics books, you may see 甲线三角, you may see 杨辉三角, which is the same as Pascal triangle. And in Western country, we use the French mathematician, which is the 16th century study of Pascal. I forgot his first name, Pascal triangle. Now we take a look at this Pascal triangle. On the first row, it's a triangle. On the first row is 1. Everything starts from 1. There is no 1, there is no first step. You are not going anywhere. So 1 go to the second step. 1 have one way to go down, 1 have one way to go down. And 1 have one way to go down this way. 1 and 1, you have 2 ways to go down. And triangle goes up here. And this, you always have 1 at the edge. Always have 1 at the edge. You can even write the 1 at the beginning, but I would prefer to write 1 at a time from left to right. 1 plus 2 equal to 3, which means there is 1 way come and 2 ways come here, get to 3. 2 plus 1, get to 3. And 1, you keep copying 1. Now here we keep copying 1. And this place is always between the previous 2 numbers. And on this side, you can put a 0 if you like. It's 0 plus 1. Okay, but we do not put that 0. We just make a limit of 1. 1 plus 3 equal to 4. 3 plus 3 equal to 6. 3 plus 1 equal to 4. And keep on writing this 1. 1, 5. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 5 plus 1, 5. Keep on writing the 1. 1 is like, what do we say? It's almost like an umbrella as a tent, triangle tent, shelf, right? 1 plus 5 is 6. Did you see the pattern? 1, 2, 3, 4, 5, 6? Okay, let's keep on. 5 plus 10, 15. I write it large so that you can see better. 20, 10, 15, 15, 5, 1, 6, 1. Keep on. 1, 7, 21, 35, 35, 21, 7, 1, 1, 8, 28, 56, 70, 56, 28, 8, 1. Okay. Up to now, we start to see some pattern. There are much more interesting things. It takes me time to learn until I get it, but I will do slowly, step by step, and we explain what we know. And there are many unknown things we do not understand, which is beyond our knowledge and beyond many mathematicians' knowledge, actually. And I think there is an endless treasure trove in this Pascal triangle, in this 杨辉三角. Always 1. Always 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can take this pattern and keep on going. It must be that pattern, because 1 plus 1 equal to 2, 1 plus 2 equal to 3, 1 plus 3 equal to 4, 1 plus 4 equal to 5. So it's always one number bigger than the previous number. So it's 1, 2, 3, 4, 5. Okay? And did you see? It's symmetric. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. Jing, 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 jing. Jing, 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 jing. Jing, 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 jing. So the number is symmetric. And this one, when you use in binomial to the power of binomial times to the power of 1, 2, 3, 4, 5 to the power of n, this is the formula to find the coefficient of the binomial. What is binomial? When we say bi, it means 2. Biscuit, biscuit is by cooked. And bilingual is 2 language. I am bilingual, I speak Chinese, English. Trilingual, I speak French, 3 languages. Bi. And biracial, your mom is from a ethnic background, your dad is from another ethnic background. Bi means 2, right? We all know binaural. So binomial, which means there are 2 terms. We can say in a mathematical term, like 2 terms are 2 variables, A and B. I would like to use A and B. And you can use X and Y, or you can use C and D. You can use any number you like. Oh, sorry. Let me put the sound a little bit low. Okay, it's too loud, my background sound. Okay, so when we see, we write down A and B, A plus B to the power of 0 equal to 1. Why? Anything to the power of 0 equal to 1. This is the rule that our previous mathematician has already settled for us. For what reason? It is beyond me, but it's settled. Anything to the power of 1 is 1. Any gibberish number, even a pie, a biscuit, even a pie to the power of 1, to the power of 0 is 1. Gosh, pies. And the rest I forgot. This is 3.1415926. This is as far as I can remember. Anyway, any number, however gibberish it is, all these numbers, any number to the power of 0 equal to 1. So this one, we can see it like, do we write this side or this side? A plus B to the power of 0. And the second line, I will write on this side, A plus B to the power of 1. So the line starts from 0, power of 1 equal to A plus B. It means A plus B times 1 time. Here, A plus B to the power of 2 equal to A squared plus 2AB plus B squared, right? So 1, 2, 1. So this one is a plus b to the power of 3 equal a cubed plus 3a squared b plus 3ab squared plus b cubed. And the same method we can figure out. I will not write down all of this. We can do a calculation. If you have time, you have the interest, you can do the calculation, and until you get, actually these are the coefficient in front of, okay, I'm sorry, that video is a little bit longer than 15 minutes, so I have to redo it. So a plus b to the power of 2 squared equal a squared plus 2ab plus b squared. So the coefficient in front of a, the first variable, is 1. And in the middle term, a and b is 2. And to the second coefficient is 1. So 1, 2, 1. Oh, it matches with this one. And a plus b to the power of 3 cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed is 1, 3, 3, 1. Oh, it matches also. So I will not keep on doing this, but if you have time and you have the patience to do it, you will figure out. I have done some of this, not all of this, but you can figure it out that it actually, these are the coefficient in front of the variables. Okay? And another thing we need to notice, the variable is like this. A plus b, let's say, to the power of 4 equal to a to the power of 4 plus a to the power of 3. There will be number here. We will need to put in the number. And because it times 4 to the power of 4, the two variables add up together needs to be 4th degree. Okay, so it's to the power of 4 and a to the power of 3, b must be to the power of 1. And this one, we can write b to the power of 0, b to the power of 1. So a is descending from 4, 3, 2, 1 till 0. And b is increasing from 0 to 1, 2, 3, 4, 5. 1, 2, 3, 4. We will write it down. The next term will be a square, b also square. So 0, 1, 2, 4, 3, 2. And the next one, a will be 1, b will be 3. And the last one, a will be 0, b will be 4, right? And the coefficient here is 1, let's see, to the power of 4. 1, 4, 6, 4, 1. I use another color of pen. So here is 1, oh, green. 1, 4, 6, 4, 1. Can you see it? 1, 4, 6, 4, 1. And we can clean it up a little bit. This one, the coefficient is 1. You do not need to write it. And b to the power of 0 is 1. Any number, however gibberish it is, any number to the power of 0 is 1. So we can write it like a to the power of 4 plus 4 A3B plus 6A2B2 plus 4AB3 plus B4. Okay, so this is cleaned up, easy to see. Another thing we notice, any binomial to the power of any number, let's say when it is power to the 4, when you open it up, time it 4 times, there are 1, 2, 3, 4, 5 items. And A plus B to the power of 10, you will get 11 items. And A plus B to the power of n, you will get n plus 1 terms. Make sense? It's always one more. Okay, let's come back to C. A plus B to the power of 0 is 1 term. A plus B to the power of 1 is A and B, 2. A plus B to the power of 2, 1, 2, 3. 3. 1, 2, 3. You got 3 terms out. A plus B to the power of 3, you got 1, 2, 3, 4. 1, 2, 3, 4. 4 terms. It's always one term bigger than the power. Okay? One term bigger, one term more than the power. Okay. Now we want to figure out. Here we have A plus B to the power of 10. And we want to figure out when B to the power of 5, what it is. You can use this Pascal number, keep on writing, writing, or you can use a formula. We will talk about this formula later. The formula is you total have 10 items, and B to the power of 5, you get 10, 的介乘, 10 factorial times 5 factorial times 10 minus 5 factorial. So it's 10, 5, 5, 10 times 8, 7, 6, and the rest of 5 will be gone. 5. I use another pens. 20, and this is 2, this is 2, so 2, 9, 18, 49, 36乘以7。6、7、42、37、21、25、2, 5, 2. B to the power of 5. A to the power of how many? A and B together must be 10, so A to the power of 5 also. Now, I need to check it out. This is actually right in the middle, remember. 19, 36, 36, 4, 7, 84, 6, 126, 126, 84, 36, 10 and 36加45 0 130 2 1 221 252 212 130 45 10 So a to the power of 5, b to the power of 0, 1, 2, 3, 4, 5. Yes, yes, we are right. We are right. I'm happy. I just manually figured it out and did not check any number. I'm so happy. I'm proud of myself. Should I? Okay, and there is a formula for it. I will. Should I talk about it? Let me do another video, okay? Maybe we stitch the 3 videos together. I love you, I really do. If I do not stitch, I love you, I really do. If I stitch, I still love you. I really do. Okay, so if we keep on writing this number, I think the whole word tree will be finished because the number is infinite. We just cannot finish writing. And the mathematicians has figured out a formula to calculate this number. Who calculated? I didn't learn about it. It needs much more profound knowledge than me. I just copied it from textbook. Okay, so the formula is I use another color, okay? Make sure that you can enjoy to see. A plus b to the power of n. And if you want to find a certain number of b to the power of r, then this number, this coefficient of a n minus r, b, r, the coefficient of this number will be the term equal to we can write the term as r, the b to the power of r, and n is the power, He is very powerful. He is the ultimate power. The ultimate power is to the power of n, okay? So we find the term equal to n 的介称 n factorial divided by r factorial n minus r factorial. It kind of makes sense, right? It means it is symmetry. If it is n minus n, it's just on the two sides of the Pascal. If this one is okay, I will use one number, particular number. So let's say not too big. Too big number will be difficult to write. 4. Here we do 7. So a plus, which means a plus b to the power of 7. And we are looking for b to the power of 4, this term. And in this case, we will figure out at least it's a to the power of 3, b to the power of 4. Make sense? Because a plus b, a power plus b power together must be 7. And now what we are looking for is this magical number. Magical number. Okay, so we can use this formula. The force, b to the power of 4, of the superpower of 7 equal to 7 factorial and 4 factorial. 7 minus 4 factorial equal to 7乘以6乘以5 4 will be out. 3乘以2乘以1, right? This is 3. So, equal 35. And on the other hand, we can see that because it's a symmetric, so when b to the power of 3, it must be the same. 3, 7. b to the power of 3 equal to 7 factorial, 3 factorial divided by 7 minus 3 factorial. So 7 factorial, 3 factorial times 4 factorial. It is exactly the same thing, right? So 7, 6, 5, equal to 35. So it is 30. So the final answer, I use a glorious color, is, what are we looking for? What are we looking for? Here, yes, here, is 35 a cubed b to the power of 4. Or when b, we can even figure out 35 a to the power of 4, b to the power of 3. Let's come here in to the power of 6. To the power of 7. Where are we? To the power of 7. So A0, A1, A7, 6, 5, 4. So 35, A7, A6, A5, A4, A3, A2, A1, B0, B1, B squared, B3, B4, B5, B6, B7. See? 35. I betcha we got it. Don't you want your polynomial hot like me? Don't you want your chocolate hot like me? Don't you want your hot like chop? Don't you want your hot like chop like me? No, gosh. Don't you want your hot chocolate hot like me? Don't you want your hot? Don't you want your hot chocolate hot like me? You have to see another video of chocolate caramel to understand this joke. I love you. I really do. I am so happy because learning something is very interesting. And when you figure out something, maybe this is the worst explanation in mathematics. But I am enjoying it. That counts. And there are knowledge. It takes time to learn. When you are in your darkest time, do not stop there. Do not be intimidated and do not be frightened and fried by the difficulty, by the hardship. It will not overcome you when you decide you stand up and do something. Don't overthink. Do not overthink. Go ahead, stand up, do some exercise. May it be mathematics, may it be physics, may it be chemistry, may it be go to gym, may it be writing a poetry, may it be painting something, or cooking something, or tikoti, weaving something, may it be anything. Do something. The best release of your frustration, the best cure of your frustration, your depression, is do something. I love you, I really do. I really do. Do. This is why I say do something. I really do. Too much time, sorry.